Cambridge International AS and A-Level Mathematics. Paper 1, Pure Mathematics 1, 2017. Answer all the questions. The total number of marks for this paper is 75. In the expansion of 1 minus 2x divided by a times a plus x to the power 5, where a is a non-zero constant, show that the coefficient of x squared is 0. So we're going to use the binomial expansion formula. So we have a, and x is b, and n is 5. So have a to the 5 plus 5 combination 1, a to the 4x1, plus 5 combination 2, a to the 3x squared, and so on. Now, when we simplify that, we'll get a to the 5 plus 5a4x plus 10a cubed x squared plus 10a squared x cubed, and so on. Now we need to multiply 1 minus 2x over a times that expansion. So we do, and we want the one that the coefficient of x squared. So the one that involves the coefficient of x squared, we would have this one. 1 times 10a cubed x squared, it has x squared. That's why we use that one. And then minus 2x over a times 5a to the 4x. X times x would give you x squared. So we're using those two. So it'll be 1 times 10a cubed x squared plus minus 2x over a times 5a to the 4x. Now, 1 times 10a cubed x squared stays as 10a cubed x squared. Plus and minus, it becomes a minus. 2 times 5 will give you 10. A to the 4 divided by a will give you a3, a cubed. And then x times x will give you x squared. So you factorize, you get 10a cubed minus 10a cubed, which is 0. So it will be 0x squared. So that's why show that the coefficient of x squared is 0. Because 10a cubed minus 10a cubed is 0. Question number 2. The function f is such that f dash of x is 3x squared minus 7, and f of 3 is equals to 5. Find f of x. So wherever the x is x to the n, then y would be that when you do integration. So when we integrate f dash of x to get f of x, because these two will cancel each other, the integral and the differential, you get f of x. So you integrate 3x squared minus 7, you get 3x cubed over 3 minus 7x plus c. So the 3 will cancel, you get x cubed minus 7x plus c. Now f of 3 is equals to 5. So you substitute x to be 3, and then you would find c to be minus 1. So put x is 3, and then you solve it, you get c to be minus 1. So f of x is x cubed minus 7x minus 1. Number 3, solve the equation. Inverse sine of 4x to the 4 plus x squared is equals to 1 over 6 pi. You put sine in front, put sine in front. So sine times inverse sine, they'll cancel each other. So you have 4x to the 4 plus x squared is equals to inverse sine of pi over 6 is half. You take the plus half to the left, it becomes minus a half. So you have 4x to the 4 plus x squared minus a half equal to 0. Now you can put y to be x squared. So x to the 4 is the same as x squared squared, because 2 times 2 is 4. So this is y. So it becomes y squared. So 4y squared plus y minus a half equal to 0. Solve that in your calculator. You get y to be 1 over 4 or y to be minus a half. Because you put 4 for A, 1 for B, minus a half for C, and you get the two answers, minus a half and 1 over 4. So x squared, change y back to x squared. X squared is equal to 1 over 4. X is square root of 1 over 4, which is plus or minus a half, plus a half or minus a half. X squared equals to minus a half. Square root of minus a half gives you root 2 over 2i if you use imaginary. So your answers are x is equals to a half or x equals to minus a half. Question number 4. Show that the equation 4 cos theta over tan theta plus 15 equals to 0 can be expressed as 4 sine squared theta minus 15 sine theta minus 4 equals to 0. Replace tan theta with sine theta over cos theta, and then you can multiply by sine theta. So we have 4 cos theta divided by, instead to divide by tan theta, you divide by sine theta over cos theta, plus 15 is equal to 0. When you divide, you change it to a times, and then you flip the fraction. So it becomes 4 times 4 cos theta times cos theta goes to the top times cos theta over sine theta plus 15 equal to 0. Cos theta times cos theta, it gives you cos squared theta. So it's 4 cos squared theta over sine theta plus 15 equal to 0. You multiply by sine theta. So you times sine theta there, times sine theta there, and times sine theta there. So you get this one will cancel here. So you get 4 cos squared theta plus 15 sine theta is equal to 0. We want to make all of them sine theta. So we can change cos squared theta to 1 minus sine squared theta. And then you remove the bracket. 4 times 1 is 4. 4 times minus sine squared theta is minus 4 sine squared theta. Plus 15 sine theta equal to 0. We can take everything to the right-hand side. So minus 4 sine squared theta goes to the right. It becomes plus 4 sine squared theta. Plus 15 sine theta goes to the right. It becomes minus 15 sine theta. Plus 4 goes to the right. It becomes minus 4, which is what you wanted to show. Part 2. Hence, solve the equation 4 cos theta over tan theta plus 15 equals to 0 for 0 degrees less than or equals to theta less than or equals to 360 degrees. So we want to solve this quadratic. We can say let x be sine theta. So this will be 4x squared minus 15x minus 4 equal to 0. Solve that quadratic in your calculator. Put a is 4, b is minus 15, c is minus 4. And you get answers of x is minus 4, minus 1 over 4, or x equals to 4. Replace x with sine theta. So it becomes sine theta equals minus 1 over 4. So theta is inverse sine of minus 1 over 4. And sine x, normally we call it sine theta equals to 4. So theta is inverse sine of 4. So you have theta to be 194.5 or 345.5. If you plot sine x in blue and minus 1 over 4 in red, so sine x in the blue graph, minus 1 over 4 is a straight line. You find where the meet between 0 from 0 up to 360, the meet at this point there, which is 194.5, and the meet at this point there, which is 345.5. So you use G solve and look for intersect. G solve and look for intersect. You will see the answers. Question number 5. A curve has equation 8 divided by x plus 2x. Find dy over dx and d squared y over dx squared. So we have y equals to 8x. We can take x to the numerator, it becomes x to the minus 1. So we differentiate it. When you differentiate 8x to the minus 1, you get minus 8x to the minus 2. You differentiate 2x, you get 2. So when you differentiate 8x to the minus 1, the minus, it becomes minus 1 comes in front, it becomes minus 8. And then minus 1 from the 8x to the minus 2. When you differentiate the second time, d squared y over dx squared, minus 2 comes to the front, so minus 2 times minus 8 gives you plus 16. Minus 2 minus 1 gives you minus 3. So 16x to the minus 3. And you differentiate 2, you get 0. X to the minus 3 can come to the denominator. So it becomes 16 over x cubed. So dy over dx is minus 8 over x squared plus 2. And d squared y over dx squared is 16 over x cubed. Part 2. Find the coordinates of the stationary points and state with a reason the nature of each stationary point. You can use this to determine the nature of stationary point, this table, or you can use this second differential. When you differentiate twice and it's bigger than 0, it's a local minimum. When you differentiate twice and it's less than 0, it's a local maximum. So we had dy over dx. We put that equals to 0. So minus 8 over x squared goes to the right. So you get 8 over x squared equals to 2. Multiplied by x squared. 8 is equals to 2x squared. Divide by 2. 4 is equals to x squared. So x equals to plus 2 or x equals to minus 2. So y would be, substitute 2 there and 2 there. Y would be 8 over 2 plus 2 times 2, which is 8. So its coordinates are 2, 8. If you substitute minus 2 and minus 2 there, y would be minus 4, which is minus 8. So the other coordinate is minus 2, minus 8. Now, d squared y over dx squared is equal to 16 over x cubed. So let's put x equals to 2. So 16 over 2 cubed is equals to 2, which is positive. Therefore, it's a minimum point. Put x equals to minus 2. 16 over minus 2 cubed, it gives you minus 2, which is a negative. So that is a maximum point. So d squared y over the x squared is greater than 0 when x is equals to 2, hence a minimum point because it's bigger than 0. D squared y over the x squared is less than 0 when x is minus 2, hence it's a maximum point. Question number 6. A curve has equation y equals to x squared minus x plus 3, and the line has equation y equals to 3x plus a, where a is a constant. Show that the x-coordinate of the points of intersection of the line and the curve are given by the equation x squared minus 4x plus 3 minus a equal to 0. So the curve is equals to the line because they intersect. So plus 3x goes to the left, it becomes minus 3x. Plus a goes to the left, it becomes minus a. So you're left with 0 on the right. Now this is a quadratic. You have x squared minus x minus 3x is minus 4x plus 3 minus a equals to 0, which is what you're required to show. Part 2. For the case where the line intersects the curve at 2 points, it is given that the x-coordinate of one of the points of intersection is minus 1. Find the x-coordinate of the other point of intersection. So you want to substitute x to be minus 1. So the minus 1 squared minus 4 times minus 1 plus 3 minus a equal to 0. So that will give you 1 plus 4 plus 3 minus a equal to 0. So that's 8 minus a equal to 0. So a is 8. Sub in the value for a, which is 8. So got x squared minus 4x plus 3 minus 8. 3 minus 8 is minus 5. And you factorize that or solve it, you get x to minus 1 and x equals to 5. You can do it using the calculator. Put 1 minus 4 minus 5 to get x is 5 and x is minus 1. For the case where the line is a tangent to the curve at the point P, find the value of a and the coordinates of P. So you have x squared minus 4x plus 3 minus a equal to 0. For a tangent, you put b squared minus 4ac equal to 0. B is minus 4, so minus 4 squared minus 4 times 1 times c is 3 minus a equal to 0. So 16 minus 4 times 3 is minus 12. Minus 4 times minus a gives you plus 4a. 16 minus 12 is 4. 4 plus 4a equals to 0. 4a equals to minus 4. Plus 4 goes there, becomes minus 4. So a is minus 1. Substitute the value for minus 1. So 3 minus minus 1 becomes 3 plus 1. So x squared minus 4x plus 4 equals to 0. Factorize that, you get x minus 2, x minus 2. So x is equals to 2. So we had y is equals to x squared minus x plus 3. Replace x with 2. 2 squared minus 2 plus 3. It gives you 2 squared is 4. 4 minus 2 is 2 plus 3 is 5. So coordinates of P are 2 and 5. Question number 7. The diagram shows a circle with center A and radius R. Diameters CAD and BAE are perpendicular to each other. A larger circle has center B and passes through C and D. Show that the radius of the larger circle is R root 2. So you look at this triangle A, B, and C. The hypotenuse BC squared is equals to the radius squared plus the radius squared. So BC squared is R squared plus R squared is 2R squared. So BC is square root of 2R squared. So square root of R squared is R and square root of 2 is root 2. So BC is R root 2. So we are using Pythagoras' theorem. Part 2. Find the area of the shaded region in terms of R. The shaded region is area of semicircle minus area of segment OCD. So area of semicircle minus area of segment OCD. Now, area of semicircle is pi radius squared over 2 minus area of sector of larger circle minus area of triangle BCD. So this sector of the larger circle, triangle BCD is the green one. So the area of triangle BCD, which is that green, colored in green there, half times the base is R plus R, which is 2R, times the height, which is R. So the 2 and the 2 cancel. R times R gives you R squared. So the area of that green triangle is R squared. The radius of the larger circle is R root 2. And area of the sector is given by this formula, theta over 360 degrees times pi radius squared. That's the area of a sector. Now, the angle is 90. So it's 90 divided by 360 times pi times the radius, R root 2 squared. So 90 over 360 is pi 1 over 4 times pi times radius squared times root 2 squared is 2. So that gives you pi R squared over 2. So that's the area of that pink part, that sector. An area of a semicircle is pi radius squared divided by 2. And that's a semicircle there. That's radius is R. You can go this way, radius is R. If you do like that, you get a complete circle. That's a semicircle. Now, the shaded area is this one, a gray that we want. Is pi radius squared over 2, that's the area of the semicircle, minus bracket pi radius squared over 2 minus R squared. So it becomes pi radius squared over 2 minus pi radius squared over 2. Minus and minus will become plus. So this will cancel to 0. So the area for that shaded region is R squared. If you were to cut it in, put on a paper and cut it and put it together, this is what it looks like. So the area of that shaded paper part is, you want an area of that's half a circle. So you want to remove, this is minus the sector minus area of the triangle. So this one can be in a bracket. So the area of a sector minus the triangle, and when you subtract them, you will get the area of the shaded part. So in small form, you can put that in bracket like that. So the area of the sector minus the area of the triangle, and then you take that away from this semicircle, you will get that shaded part. Question number 8. The first term of a progression is 4x and the second term is x squared. For the case where the progression is arithmetic with a common difference of 12, find the possible values of x and the corresponding values of the third term. So the first term a is 4x. Second term a plus d is x squared. And for third term a plus 2d, fourth term a plus 3d, n term a plus n minus 1d. So the common difference is 12. That means a plus 12 is equals to x squared. And a is 4x. So 4x plus 12 is equals to x squared. Take x squared to the left, or put them together. 4x goes to the right, it becomes minus 4x. 12 plus 12 goes to the right, it becomes minus 12. So we got x squared minus 4x minus 12 equal to 0. When you solve that quadratic, you will get x to be minus 2 or x equals to 6. We use the third term is a plus 2d. And 4x plus 2d, put x is minus 2. 4 times minus 2 plus 2 times d is 12. It's 2 times 12. Minus 8 plus 24. So the third term would be 16. 24 minus 8 gives you 16. If we have x is 6, 4x plus 2d, x is 6. So 4 times 6 plus 2 times 12, because d is 12. So 24 plus 24, the third term is 48. Part 2. For the case where the progression is geometric with a sum to infinity of 8, find the third term. So for geometric, the first term a is 4x. Second term a times r is x squared. And the third term is a r squared. Fourth term a r cubed. N term a r to the n minus 1. That's the formula for s infinity. A to the over 1 minus r. So s infinity is 8 is equal to first term is a, which is 4x over 1 minus r. Common ratio r is second term divided by first term. X squared divided by 4x, one of the x will cancel. So you have x over 4. Now you can take x over 4 and replace it there for r. So 8 is equal to 4x over 1 minus x over 4. Cross multiply. 8 times bracket 1 minus x over 4 equals to 4x. Remove the bracket, 8 times 1 and 8 times minus x over 4. So that would be 8 minus 2x is equals to 4x. Minus 2x goes to the right, it becomes plus 2x. So 8 is equals to 4x plus 2x is 6x. So x would be 8 divided by 6. We divide by 6. X is equals to 4 over 3. Now you take that x as 4 over 3, you sub it in there. So r is 4 over 3 divided by 4, which will gives you 1 over 3. So your third term, a r squared, is 4x times 1 over 3 all squared. And so it's 4 times 4 over 3, because x is 4 over 3, times 1 over 3 squared. So that gives you 16 over 27, or 0.593. Question number 9. Express minus x squared plus 6x minus 5 in the form a bracket x plus b all squared plus c, where a, b, and c are constants. So we're going to use this formula here. A is minus 1, b is 6, and c is minus 5. So we substitute those numbers. A is minus 1, b is 6, and a is minus 1, there 2 times minus 1. C is minus 5, b is 6, a is minus 1. Substitute those numbers and simplify. You get minus bracket x minus 3 plus 4. So that's what you get, x minus 1 bracket x minus 3 all squared plus 4. The function f such that minus x squared plus 6x minus 5 is defined for x greater than or equals to m, where m is a constant. State the smallest value of m for which f is 1 to 1. The smallest value for m is 3, because at this point 3, you can find the inverse. Question number 10. The diagram shows a cuboid OABCPQRS with horizontal base OABC, in which AB is 6 centimeters and OA is 8 centimeters, where A is a constant. The height OP of the cuboid is 10 centimeters. The point C on BR is such that BT is equal to 8 centimeters and M is the midpoint of AT. Unit vectors I, J, and K are parallel to OA, OC, and OP respectively. For the case where A equals to 2, find the unit vector in the direction of PM. So we want AT. So from A to T, we can go from A to B and then B to T. So to go from A to T, we can go from A to B and then B to T. So AT is AB plus BT. Do we know AB? AB is 6, so 6I, and BT is 8K. AM is half AT, which is half of 6I plus 8K, which is 3J plus 4K. Half of 6 is 3, half of 8 is 4. PM is equals to PQ plus QA plus AM. So PM, that will be minus, to be 2I minus 10K plus 3J plus 4K. So 2I plus 3J minus 10K plus 4K. So PM is equal to 2I minus 10K plus half times 6J plus 8K. So that gives you 2I plus 3J minus 6K. Absolute value of PM would now be 2 squared plus 3 squared plus 6 squared, which gives you 7. So the unit vector is PM divided by absolute value of PM. So 1 over 7, absolute value is 1 over 7, times 2I plus 3J minus 6K. So this is the formula to find unit vector. For part 2, for the case where the angle ATP is equals to inverse cosine of 2 over 7, find the value of A. We know AT is 6I plus 8J. PT is the same as PQ plus QR plus RT. So that's PT is the same as PQ plus QR plus RT. So PT is equals to AI plus 6J minus 2K. But we know AT is 6J plus 8K. PT is AI plus 6J minus 2K. So we have cosine of ATP is 6I plus 8K dot AI plus 6J minus 2K over the magnitude of those expressions. And you would use your calculator to simplify them to get 2 over a squared plus square root of a squared plus 40 is equals to 2 over 7. And that will give you a to be 3. Remember, square root of 36 plus 64 is 80 because 6 squared plus 64. So your value for a is 3. And we're using this dot product here. And we're using this cosine rule here. So these are the formula that we're using. So at.pt, 0 times a plus 6 times 6 plus 8 times minus 2. That gives you 20. So cosine of ATP is equal to 2 over 7. You cross multiply, 7 times 2 is equal to 2 times that. And the 2 will cancel. So 7 is equal to square root of a squared plus 40. Square 7. So 49 minus 40 is equal to a squared. So 9 is equal to a squared. So a is square root of 9. That gives a to be 3. Question number 11. The diagram shows part of the curve y equals to 1 plus 4x to the power half and the point P 6, 5 lying on the curve. The line PQ intersects the x-axis at Q 0, 8, 0. Show that PQ is a normal to the curve. So go y equals to 1 plus 4x to the power half, dy over dx. When you differentiate that, you get 1 over 2 times bracket 1 plus 4x to the minus a half, because half minus 1 is minus a half, times 4. Because when you differentiate 4x, you get 4. Now you substitute x is 6. So that gives you 1 over 2 bracket 1 plus 4 times 6 to the minus a half times 4. Simplify that, dy over dx equals to 2 over 5. So P is 6, 5 and Q is 8, 0. You want to find the gradient. So 0 minus 5 divided by 8 minus 6 gives you minus 5 over 2. And using this formula, m1 times m2 equals to minus 1. So 2 over 5 times minus 5 over 2 equals to minus 1. Because we had here 2 over 5. For part 2, find, showing all necessary working, the exact volume of revolution obtained when the shaded region is rotated through 360 degrees about the x-axis. In part 2, you may find it useful to apply the fact that the volume V of a cone of base radius r and vertical height h is given by V equals to 1 over 3 pi radius squared h. Using this formula for the volume of revolution, V for volume is equals to pi integral from 0 to 6. Y squared is 1 plus 4x to the half all squared dx. Half times 2 will give you 1. So it's integral from 0 to 6, 1 plus 4x dx. When you integrate 1, you get x. Integrate 4x, you get 4x squared over 2, which is just 2x squared. 4 divided by 2 is 2. From 0 to 6, substitute in 6. And then after that, you do the same, substitute in 0. You get pi 6 plus 2 times 6 squared will give you 78 pi for the volume. Using this formula, V equals to 1 over 3 pi radius squared h. Volume for the line is given by 1 over 3 times pi times 5 squared times 2. Because we're using that 5 then. So it gives you 50 pi over 3. So the total volume is 78 pi plus 50 pi over 3. It gives you 94 and 2 over 3 pi, or 284 pi over 3. So you can see that if you rotate a triangle, it will form a cone. If you have a triangle, you rotate it around the x-axis, it will form that cone there. That's why we use volume of a cone. So you can see a triangle there, and you rotate the triangle, you form a cone.